Yeah, welcome everybody. So the two applications dashboards before are very interesting and helpful, do a lot of analytics and so on. But we also thought about, well, what can we develop to allow users to analyze the air quality and traffic and so on in the near surrounding. Yeah. So if you go outside, if you're walking for example, going to work, what is the air pollution around you? What's the air pollution in the proximity? And furthermore, we also looked into some new technologies, and therefore we thought about creating an augmented reality app to use latest state-of-the-art technology and using the AR capabilities of modern devices. So therefore, this led us to the development of the Dynamic Exposure Visualisation App. As said, the objective was to allow everybody to explore the air quality and traffic. And this should be done in an easy way with mobile devices. Everybody has a smartphone in his pocket, so you should use your device, which you always have, and can explore with the device the air quality and traffic in your neighborhood. Yeah. So, but this challenging objective contains a lot of challenges. So first of all, there is currently no augmented reality app available on the market, which offers any kind of visualization of real-time environmental data. So there were some attempts in the past, but they stopped their development. So at the moment, there is nothing out there. Secondly, the question arised: how can we visualize 3D data from measurements from sensors? Yeah, if we have air quality, air pollution sensors distributed in the city, how can we visualize these 3D data in an augmented reality app? And yeah, and it should also be easy to use. Yeah, we need to develop an UI which is simple to use, which helps the user quickly get an idea about the air pollution and its surrounding, and should also be appealing to attract the user to use this application. And more technical challenges to develop a software framework which is flexible, which is able to integrate future sensor data, which is able to access different kind of servers which are offering air quality measurements and so on. Beyond these general challenges, there are some specific challenges if we talk about how to visualize 3D sensor data in the augmented reality application. So we only have 2D positional information available. So therefore, there is perhaps sometimes overlap of data. So therefore, we need to think about how to visualize close data and far data and so on. If we visualize data which are, for example, 500 meters away, perhaps they become too small. So we need to think about how to visualize data at different perspective, at different distances, and so on. And sometimes the perspective parallax of the real and the virtual objects contradicts each other in the augmented reality view. So this led us to a system which is briefly depicted here. So on the left-hand side, you see the different sensors from the project, which we developed and offered from the Compare project, but we are also able to access do-it-yourself community sensors. All these data are managed in a data manager, and then via an API, they are provided or can be accessed by the air quality framework, which manages the application on the mobile device. And there are a lot of different building blocks, where the 3D data are requested from the servers, different visualizations, different attributes, different user interfaces, and so on are realized here in this framework. And finally, we have a renderer and the graphical user interface, which serves the smartphone or the tablet. Yeah, and if we talk about visualization, it's not just a citizen science project, but also has some scientific challenge. So therefore, we developed novel modes for visualization. So here are these different type of modes which we developed in this context to allow the user to see 3D spatially distributed 3D data in augmented reality. Yeah, so we can see near and far distant sensor data in different ways, and the user can choose between different concepts and identify the most appealing one. So as already mentioned, UI is key for such kind of application. So therefore, we looked carefully together with the users in our pilot cities on the design of the user interface. And therefore, we came up with a simplified exploration mode where there is just a little possibility to make selections and set parameters. And here are some screenshots provided, how data can be selected and how the sensor information of a distinct sensor is visualized. So there is another interesting feature which we also developed, and this is kind of input for the next presentation of Jürgen. So this special feature is the trip recorder. So as we have a device at hand which is able to track GPS positions, we are able to record a trip. And if we use another sensor, if this sensor is you're taking a sensor on your trip, then we can relate the measurements of the sensor with the GPS positions. And this allows us to monitor the air pollution or the air quality along the trip you were taking. And so this tool here serves as for the input for the Dynamic Exposure Visualisation Dashboard, which is presented in the next talk by Jürgen. Yeah, finally an outlook. So this app is now in its pretty prototype state. It is runs on state-of-the-art mobile devices, but there's one major requirement: the devices needs to have air tracking capability, which is obvious for this application, but most of the state-of-the-art devices are able to do so. So the app is currently evaluated in different pilot cities and regions, and we receive feedback to further improve the app and so on and so forth. And the overall goal is to make this application publicly available in the two major stores, in the Google Play Store and in the Apple Store. So by in summer this year, we aim to make this available, and we will certainly announce this via social media if the first version is ready for download. And by the way, I can show you on the most recent iPhone Pro. I can show you that the app is installed and running. So yeah, this iOS version is also available now, and yeah, we're looking forward to the publicly available version. And as the question came up in previous talks, we are also supporting multi-languages. The main language of the user and of the smartphone is identified. So if you are Greek citizen, or the app automatically starts in Greek language, and yeah, and we support all the other project languages: Bulgarian, Dutch, German, and English. Thank you very much for your attention.
Great stuff there, Oliver. Thanks a lot for the presentation. I noticed in one of your earlier slides, you show the different sensors that are already plugged into the DEVA pipeline, like sensor community and sensors we're using in the project. Is it possible to plug data from reference station, from European Environmental Agency, for example? Is the architecture flexible enough for that?
Yeah, that's a very good question, and that brings me to an important point. I mean, if you remember the map of sensors, depending on the activity of the citizen science community, there might be some neighborhoods where is just a poor distribution of sensors. Yeah, so if you use your app and you walk around, you will not necessarily find sensor information around you. Yeah, so might happen that 5 kilometers away the next sensor is. So therefore we thought about, well, what kind of data could we also integrate? And there is another service available, which is called Breezometer. They offer model data. So based on publicly available air quality measurements, they derive an air quality model, which provides air quality values every 500 meters. Yeah? And we plan to include this air quality models in our app to offer air quality and information anywhere, everywhere you are, and being independent of the real distribution of do-it-yourself sensors. Yeah? And for sure, the software framework is flexible, very flexible to include additional services, additional do-it-yourself sensors and so on, but also it allows to access other community sensors and so on.